You know, if you're not sure, because we can do the counting.
Yeah.
Do I have to stop? It's not like what I'm counting.
Well, it's the horse, the counting thing, yeah. But I don't care which foot, I give you some leeway here. All right, so let's, I just want to just run through really quickly how to draw the graph from an equation, how to write the equation from the graph, and then how to calculate slope without having to graph it. Stuff we've already done, just sort of one last, okay, let's make sure we got this, and then we'll move on. We'll practice it the rest of the class, and then on Monday, we're off on something else.
Oh, wow.
Yeah, okay. All right, so let's try, first of all, let's do I got an equation, I got a graph, and I want to write the equation for that. All right, so I've got a graph that looks something cleverly like this. Again, if I've got a graph that's naked like this, no words, no nothing, that doesn't have any context to it, I'm going to always make this degrees and hours. Because I understand that, right? Degrees, the temperature goes up, the temperature goes down. This is for you. This is right. All right, and then time marches on, right? So let's say I've got a graph that looks like this. All right, looks like that. I want to write the equation for this guy. Yep. All right. And this is a perfect graph, so you should be able to figure it out. All right, so remember the general formula of this, right? That y equals mx plus b. Yeah. What was the b?
The starting point.
That's the starting value. Because remember, I'm going to keep track of the temperature over some period of time. So I want to know when I started to get ready to start the clock, what was the temperature? Because that matters, right? So that's the starting value. The math term is y-intercept, right? That nasty, ugly thing, aka y-intercept. All right. And how about this guy? The m.
The slope.
Is the slope was one word. What's another phrase?
How fast
How fast?
can you change?
Yep. All right, so where did we start?
Could it be?
Right? We know we're going to have, it's going to be some form, y equals something, x, and then plus or minus something else. Yeah. So we're going to start with the b, right? Because the m, the slope, that's going to tell us how steep it is, but I don't know, is it like here, is it here, is it here, is it up there? Where does that line go? So I need to be able to differentiate parallel lines and say it's this one. So we start with the b, right? Where it crosses, this is before any time goes by, right? So the starting value is before anything, so it's always on the y-axis here. Yeah. So here it's a positive 2. Yeah. So now I know I'm going to fill in a positive 2 here, right? That came from that guy. And now, the second step, I'm going to use this slope to figure out, I'm going to count to figure out what the slope is, or the rate of change, or how fast.
Okay.
So remember, from here to there, going up, that's the how much, all right? Up and down the degrees, how much did the temperature change there, divided by how long? Yeah. So how much did it change?
3.
3. Yeah. So the 1, 2, 3 went up there. So I've got the how much,
And then 4.
and then the 4 is 1, 2, 3, 4. If this, I can't reduce this. Done. Yeah.
Yeah.
Question about this?
Oh.
So, no.
Duh. No. Okay. So I know. All right.
I'm just
Serious
kidding.
stuff. Yeah, we'll see on next
Right.
Monday or Wednesday how.
This will be Chinese to me.
Excellent. All right. Oh, we're good here, but I want you to have one reasonably good example. And remember, we talked about whether a slope is positive or negative. Yesterday, I had the greatest thought I've ever had in this math stuff, right?
So
So how are you going to remember which is positive and which is negative slope? What's the first letter in the word negative? I'm so proud of this.
An N,
It's an N, and look at an N. How do you write an N? Not
up
how
and down.
If the line leans this way, it's
Oh.
negative, and it doesn't matter whether it's a steep line, or it doesn't matter whether it's a shallow line. If it leans that way, all right.
You should get money for that one.
I earned my money for this one, that's
So
right.
it went up.
Okay, so no more which is which, right? It's all.
Negative.
All right. Yeah. All right, so here we go, again, the same formula, but now we're gonna go the other way, all right? We're gonna write the equation and then figure out what the graph is.
Yeah,
Can I erase this? Do I have to? I will.
cause most, like, when you see.
All right.
a problem, it'll
So this time we got an equation.
What's the wire?
How about this guy? All right, so we wanna graph this. yeah? All right. Couple of negatives just for you. All right, down here, -1, 6, 2. All right, okay, so where do we start here? That's right, we're gonna start with the y-intercept, right? Because that's gonna sort of anchor this whole thing, and then we'll figure out. So the y-intercept we said was this guy.
Yeah,
So it's a -4. Oh, look at that all the way to the bottom. Okay, -4, yeah. And again, it's always on the x-axis, right?
Mhm.
So that's where we're gonna start.
Y-axis.
Y-axis, I said y-axis, the sun like that. There's an echo.
It's on
there.
there.
Okay, so it's a -4. All right, and now we got this guy, we're done with this, right? It's got nothing to do with anything from this point on. So the 2 is the slope, the rate of change, the how fast.
So it went up 2.
Okay, right, we need to make a fraction out of it, right? Because we gotta have 2 numbers, we've gotta have a how much and a how long. And how do we do that, make a fraction?
we did 4/1. Oh, 2/1, I'm sorry.
2 see, it's catchy. All right, so the 2, right, and again, this is a naked graph, so I'm thinking degrees and hours to make sense of it. So it went up, it's a +2, went up 2 degrees, right? Here we are going up 2 degrees. And how long did it take to go up 2 degrees? It took 1 hour, right? So 1 hour is here. So my next point is gonna be right there, up 2 and over 1. Yep. Connect the points, and we are out. And we can do the up 2 over 1, up 2 over 1, up 2 over 1 forever and ever, amen. Yeah? This is the nodding part.
Yes,
All right, cool. So we know how to do these. Any more, do we need to do another one, or are we okay here?
we're okay here.
All right. All right, one more, and then I'm gonna turn loose to frustrate yourselves. I got a line, see, I got a line, and I got one point on that line is this, and then another point on that line is this.
On that graph you just drew, but you just erased it.
What about it?
I just wanted to know, once we went up to, from the starting, the -2, we started here, but we went up to, and then we moved over 1 to get to the 1 hour?
That's right.
Okay. Okay.
So the how much was the up and down,
Right, okay.
okay?
I have a question.
Excellent, yeah.
Is that 12?
That is 12?
Here we go, Dan, yeah. Dan just chastised me, I gotta work on my writing, so that's a -12. Maybe I'll just speak them as I write it, 4 comma. All right, calculate this. We can figure which one's 0.1 and 0.2, or we just, the
Like we
difference.
just did this morning.
We just did this.
Oh my God!
I'm so happy you remembered, it was a long time ago, it was like 8 minutes ago.
I
All
got
right,
it!
So we'll call this,
What is that?
0.1 and this one 0.2. Yeah, that's like the Dr. Seuss. Do you know that thing 1 and thing 2?
Yeah.
Anybody know Dr. Seuss?
Yeah.
Okay, so what was the general formula for calculating this?
4
Well,
minus
the general,
5 minus y.
and which y?
Both of them.
To somebody else
Why
said,
two?
why, alright, let's make this 2 and 1,
Oh.
for no good reason, alright? So if they're 2 and 1, what are the X's?
1 and 2.
2 or
Two and
more.
one.
Alright, alright.
I'm messing with him. I'm messing
Okay, so now we can plug in numbers, right? So we'll pull this from point 2, right? So the Y value, which is the negative 12, yeah? And we're gonna subtract this guy.
Why did you
Subtract,
start from point 2?
because that has a 2.
You can arbitrarily start either way, but he chose to start with two.
Yeah, I just named them, doesn't matter which is
Okay.
which.
Alright,
So this is a negative 12 minus, and the other number is a negative 6. So I'm subtracting a negative 6.
Which would be 6.
Alright, and then on the X part, I got 4. These two have to come from the same point, right? That's 2, that's point 2, they gotta be the same one. So this is gonna be 4 minus, again, minus a negative 2, minus a negative 2, yep. So this guy becomes a
negative 6. What's it?
Positive 6.
Positive 6.
positive, yeah, you're ahead of me, yeah, positive 6. Negative 12 plus 6, right, which is the tricky triangle, right, these two cover them up. And then a 4 minus a minus 2 is 4 plus 2. And negative 12, positive 6,
Negative 4.
negative 6, right? Go 12 in this direction, only come back 6. Negative, or 4 and 2? 6, so we could reduce this to what, negative 1? So this this graph, if we graph it, would be changing by negative 1, down 1 degree for every hour. So it would be a negative slope. It would run that way. Good here?
No.
No?
I get the math, but I'm confused about the, negative and positive, because when I said negative 6, you said no positive, but it was negative 6.
Well, the answer ended up negative 6. I was asking about this.
Oh,
Just
okay.
this.
So I skipped that, I was skipping that part.
That's why I said you were ahead of me. Yep.
Okay.
You and everybody else. Okay? Yeah, we're good. All right, let's kill this and we'll, turn you loose on the, Mr. Kirk Webb.